Section 11.2 is probability. I can find the probability of an event using theoretical or experimental methods. Big ideas. The probability, P, of an event is a number such that 0 is less than or equal to P less than or equal to 1. So P is in between 0 and 1, or we can think about them as percents, as P is in between 0% and 100%. The probability of an impossible event is 0 or 0%. If it's impossible, it can't happen. There's a 0% chance that it will. The probability of a certain event is 1 or 100%. If we know for sure it's going to happen, 100% of the time it will, which is a probability of 1. Take note on page 681, talks about experimental probability. The experimental probability of an event is the number of times the event occurs divided by the number of trials. So of the 60 vehicles in the school parking lot today, 15 are pickups. What is the experimental probability that a pickup in the parking lot, or that a vehicle in the parking lot is a pickup truck? So our probability of pickup is how many times it occurs out of how many total options. Okay, out of how many total things. We divide that and you get 0.25. You also could do 25%. So there's a 25% chance that if we pick a vehicle out of the parking lot, it's going to be a pickup truck. I think in our parking lot it's probably higher than that. Now, a softball player got a hit in 20 of her last 50 times at bat. What is the experimental probability that she will get a hit on her next at bat? Okay. Probability of a hit, that's what we're looking for, is how many times she's gotten a hit out of how many times she's tried, which is going to be 0.4 or 40%. The set of all possible outcomes to an experiment or activity is a sample space. So all possible outcomes is our sample. When each outcome in a sample space has the same chance of occurring, we say that the outcomes are equally likely outcomes. Okay, when we roll a set of dice, okay, each number is equally likely to occur on the die. When we draw a card out of a deck, each thing is equally likely. Times when they're not is if we have like a bag of marbles and we have 4 red and 10 white. Okay, it's not as equally likely that we draw a red as it is a white. Okay, there's the difference there. For one roll of a standard number cube, guys, this is how they say a die, like a dice, but one, a die, standard number cube. The book's weird. Just go with it. There are 6 equally likely outcomes in the sample space. We can calculate the theoretical probability as a ratio of outcomes. So, experimental probability has to do with the amount of things that we can see or that have happened, whereas theoretical probability is all based off what probably would happen because of equally likely outcomes. So, if a sample space has n equally likely outcomes, and an event A occurs in m of those outcomes, then the theoretical probability of the event A is m over n. So here's the outcomes we want. Over total possibilities. Example 3 is finding theoretical probability. What is the theoretical probability of each event? Okay, so our probability of getting a 5 when we roll a standard number cube, so when we roll a die, a probability of getting a 5. Well, our options when we roll a die are 1, 2, 3, 4, 5, or 6. 6 total options, so that's our sample space. The amount of times it could be a 5 is once, so 1/6. Okay, we could write that as a decimal or as a percent, but we don't need to. We can keep it as 1 out of 6. How about getting a sum of 5 in one roll of 2 dice? Okay. Okay, we need to figure out our sample space. And we can use our counting principle here. The number of options for the first die is 6. For the second die is 6. So we multiply those together and we get 36 total options. We get a 1 and a 1, a 1 and a 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2, and so on. Okay, 36 total options. So the amount of times that they can add to 5, if we had a 1 on our first die and a 4 on our second, a 2 on the first, a 3 on the second, 3 on the first, 2 on the second, and 4 on the first, 1 on the second. Those are all the possible times that we could get a sum of 5. And there are 4. We always want to reduce our fractions or simplify if we can. Again, we can write this as a decimal if we want to, but instead I'm just going to write it as 1/9. Which means when you roll a pair of dice, you have a 1 in 9 chance, theoretical chance, of getting a sum of 5. The experimental chance would have been if you've rolled 36 times and gotten a sum of 5 10 times. Okay, that would be your experimental probability based off what has actually happened, where theoretical is based off what should happen, based off the options. Now, what is the theoretical probability of getting a sum that is an odd number on one roll of 2 standard number cubes? So if we roll 2 dice, what is our probability that our sum will be odd? Okay, we need to figure out our sample space, which is our total number of options. So on our first die, there are 6 possibilities. 1, 2, 3, 4, 5, 6. On our second one, there are 6 possibilities. So we multiply those two together, according to our counting principle, and get 36. Now, we need to figure out how many sums are going to be odd. Keep in mind that in order to add to an odd number, we have to have one odd and one even. So, odds are 1, 3, and 5. And we can add those to evens, 2, 4, 6. 3 we can add to 2, 4, and 6. 5 we can add to 2, 4, and 6. Okay? We can also have a first number that's even, 2, 4, 6, and add to it an odd, 1, 3, 5. And 1, 3, 5. Okay? This is kind of like a, I can't remember, stem and leaf plot. Right now I have 1, 2, 1, 4, 1, 6, 3, 2, 3, 4, 3, 6, 5, 2, 5, 4, 5, 6, 2, 1, 2, 3, 2, 5, 2, 1, 2, 3, 2, 5, sorry, 4, 1, 4, 3, 4, 5, 6, 1, 6, 3, 6, 5. So we're going to have a total of 3, 6, 9, 12, 15, 18. Okay, which makes sense. If half the numbers are odd and half are even, then half the time we're going to get one odd and one even, the probability of each event, which is going to be 1/2. So the probability that our sum will be odd is 1 out of 2. And that is all for this first video.